So good morning, I am Anurag Kumar and today I am going to solve the maximum subarray product problem. So let me open this on LeetCode. So signing. So let me read this problem. Given an integer array nums, find a subarray that has the largest product and return that product. The test case is inline, so the answer will be fit in 32-bit integer. So this is the test case given. Actually, we have to find the maximum product of a subarray. So subarray is basically uh, part of sub contiguous part of a array, like 2 3, like here 2 3 2 3 minus 2 3 minus 2 3 minus 2 4 minus 2 4. So the brute force to solve this problem is to generate every sub array and and take the maximum of that generate the product of every sub array and take the maximum product generated in all those sub array. So for that we have we I'm going to write the code. No, let me first explain how to let me do a drive like this test case. So by solving it from two for loop, firstly we set positive point the I pointer here and the, and j pointer here. So firstly uh, we will start from 2 and 2 and move the j pointer here, actually pointing to 3, so include 3. And doing all this we will keep taking the maximum product of the uh, maximum product as generated till now, and then we move the pointer here and include minus 3 and 4. And similarly after the j points uh, landed on the last index, we move the I here and again start taking product from the uh, one index. Let me index this array 0 1 2 3. So 3 minus 2 and 4. J will again start moving from here and here. So doing in this way we can easily find the maximum product, and that is in the sub array. So I'm going to write the code. So firstly I will take the size of the sub array, that is nums dot size, and we will initialize two for loop, one starting one of I and another of j, that will run from 0 to n minus 1 index in I plus plus, and again a second for loop in which we will start from I, every I, and that j will run from I to n minus 1. And we will keep taking the product of every subarray into product, and product equals to we will initialize it with 1. So we will take product into nums of I, and doing all this we will initialize another variable and at the upper loop into max product, that is int min max product is equals to max of product and max product. So let me format the code, and lastly at the end of the loop we will simply return the max product. Right. No, here it is J. It should be J. We can say the problem is accepted, but it is a brute force and it has a complexity of O and square because we are running two loops. So I'm going to explain the O of n approach. So for that, we will simply take another test case like another test case of another test case like the same 2 3 minus 2 4. So according to the question, the array in array we can find all positive numbers. This is the first case, all positive numbers. And second test case will be all no. I will include it in first case as well. All positive number, all negative number. So in this case, if we will take the whole product of the array, so we will get the maximum product. So this is case, and second case is we will get odd number of odd number of negative integers. So in this case, we have to take care of finding the maximum product by by not including a negative number. So like this, here minus 2. Either we will find the solution in this part or the solution in this part. We have to exclude the minus 2 always. Like you can say that the answer here is 6. 2 into 3 6, and in this part you can say that it minus 2 minus 1. As this minus 2 and minus 1 are not sub-array because they are not contiguous, so here the result is 2. Here output is 0. So in this case, we not include the minus part and always take the result between uh, this and this, suffix and prefix. It is prefix and it is suffix part. Uh, so let me take a big test case that will explain much better. Minus 2 3 4 minus 1 0 minus 2 3 1. So here you can say that there are odd number of negative integers. So we will always we will always get the maximum product sub array in the part of the array has which is which have always even number of integers or no negative integer like this part. Also, You will always get the product in the part which have a odd number of no odd even number of integers. So here we can say that there are only two even integers and here are no any odd integers and it means zero integers. So we will always take the product of this part, this part. So another test case is that what if we find a zero at any place? If we find zero at any place like this, we will exclude the that zero because g because there are some other maximum product other than zero. In case of zero, we have to exclude it. So uh, how to implement this problem? So basically, we will start from uh, here I and j. Not I and j. We will take a prefix product and a suffix product and key and run from here and here. So at the start of prefix will be -2 and suffix will be 1. So we will keep taking the maximum of these two and then we will move further, come to 3. So we will multiply it with 3 and multiply it with 3 and take the and we'll keep taking the maximum of both the prefix and suffix. So we move further 4 and we move further -2 and keep taking the uh, maximum of prefix and suffix. So we will move to -1 and 0. So here is the 0 suffix. Let me mark the suffix as I iterating to the in array. So you can see that currently it's prefix, it's suffix. So currently you can say that the prefix is here and suffix is here, and currently the product is -2 3 4 -2 -1 3 4, and its product to 12, not 12, it's 14, and this will result to 0 and this will result to 24. So we will take the maximum of this product, maximum of this prefix and suffix, and we will keep moving the pointers forward. Like s will come here and p will come here, and in the case we get any 0, like here we will re-initialize the suffix or prefix with 1 because there is no any benefit of taking the 0 forward because in any case what if we will get the big product in traveling in further, like in this direction or prefix in this direction. So we will keep taking the maximum prefix and suffix and take care that if we got the product of prefix and suffix at 0, we will re-initialize it with 1. So here is the approach from which we can solve the problem of and complexity. So let me code this. So we can simply this the max product is increment. So we will initialize two more variable, that is prefix and another prefix with 1 and suffix with 1 also, and we will keep multiplying our elements, keep taking the product as we move in the array. So nums of I going from the forward direction and the suffix into nums of n minus I n minus I minus 1. Because when we have to calculate the product from the or access the element from the back of array, we can simply do it with n minus 1 minus I. So let me take an example of this. So suppose we are currently on minus 2, minus 3, minus 1. Suppose we are currently at this index 1 index. Suppose we are currently at this index, that is 0 1. So doing n minus I, that is 1 minus 1. So what it give? uh, N is we can say that 1 2 3 4. 4 minus 2, 4 minus 2, that is 2. So our the pointer coming from the back is at this point, 0 1 2. So in this way we can traverse from the forward and backward direction of the array at using a single loop. So we take a multiplication of this, and we will take the product of maximum of the product. So max of, and here we can here we have to calculate the max of three things. So we will store it with it in array, and will comfortably take the maximum of these products. So suffix is here. So we will multiply it all the, and the edge case that I have mentioned. What if we get our product as 0? uh, so we will simply, if prefix found to be 0, I will simply initialize it with 1, and simply for, and same for the suffix equal to 0, suffix equal to 1. Let me format the code. Run it, get accepted. So it is accepted, and here I'm saying the complexity has improved a lot.